Hello, everyone, and welcome to the virtual planetarium from the Museum of Science. My name is Emily. My pronouns are she and her, and I will be your moderator during this program. So that means that if you are watching us in Zoom, you have the ability to send us questions or comments throughout the program, and I am the one actually watching those questions come in, and I can relay that information to our main educator today. So if you have a question, you can drop it into the Q&A box on your screen. We're also offering live captions. So if you would like to see captions, you can click on the CC button on your screen and then select Show Subtitles. So with that, we can welcome our educator and we'll get started.
Thanks, Emily. Hi, everybody. My name is Katie. My pronouns are she and her, and today I will be your educator as we continue our month of planets. I will also be operating our visuals for today. Sadly, this is our second to last week of virtual planetarium, but we are, of course, very excited for these last two programs. So far we have talked about Mercury, Venus, Jupiter, and Saturn. So today naturally would be the Earth and Uranus. So we get one rocky planet and one gaseous planet. But since I am not a geologist, I don't know that much about the Earth. We're going to be talking about the Moon and Uranus for today's program. So I'm going to switch us over to Worldwide Telescope. This is a free and open source software that you can use. You can download it. You can also, believe there's might be a web version as well at worldwidetelescope.org/download, but it basically simulates our solar system and our galaxy, and you can kind of fly around, and you can even use like a little Xbox controller, and it's pretty fun. Kind of feels like you're playing a video game. But our first stop will be to our moon. Now, most of the moons in the solar system have names, but ours is it's the moon, so it doesn't really have a name, but in other languages, sometimes it's called, it's La Lune. So sometimes folks will call it Luna, but it is the moon, and it's in orbit around our planet. Let me make these really big. That way we can see it. I'm going to make them like really huge. So here we go. We can see our planet Earth over here and the moon. Now, this distance between the Earth and the moon is about 250,000 miles. And the moon, compared to the size of the Earth, is actually quite big compared to other moons around their planets. So we have a large moon, and we can zoom in a little more here and look at the side that we all hopefully recognize, because if you ever look up at the moon during a full moon, this is the side you will always see. The moon is tidally locked with the Earth, meaning that the same side is always facing our planet. So no matter when you stare up at the moon from the surface of the Earth, you are going to see the same side. So this kind of gives the illusion that the moon doesn't rotate, but it actually does rotate. It just takes the same amount of time to rotate as it does to orbit around the Earth. So for the moon to make one orbit, that takes about a month or like 28 days. Kind of depends on how you're measuring it, but it's around 28 days. And it also takes the same amount of time to spin once. So that's what makes it tidally locked. Now, we do have an idea of what the other side of the moon looks like, because we have sent spacecraft and satellites to take pictures of the moon. So if we fast forward time, that way I can give you like a full view of the moon. Here we go. We're going to go like a few weeks into the future here. And you can actually see that rotation a little bit easier. You can kind of see how phases work. If you were standing on the surface of the Earth, you'd be seeing different parts of the moon. All right, there we go. So this is the far side of the moon. And the reason I'm not saying the dark side is because it as you can see, is very full of light. It's reflecting light from the sun. And if you were standing on the surface of the Earth and looking up at the moon, this phase would be the new moon phase. You wouldn't actually be able to see it because the side that's facing us is not getting the sunlight. It's the opposite side. But you'll notice that there's a lot of difference in the features. There's not as many like darker areas, and a lot of this is still a mystery to scientists. So we can kind of go back and take a look at the history of our moon, because there are many different hypotheses about its formation, but there's one in particular that has the most solid evidence, and that's called the giant impact theory. I can show you an artist's rendition of what this may have looked like. So the solar system formed about 4.5 billion years ago. And in the early solar system, it was a pretty chaotic place. Objects were very hot, made of molten rock, and objects were very close together. So there were a lot of collisions during this time in the solar system. And it's thought that a very large object, probably about the size of Mars, called Theia, actually collided with the Earth, or what the Earth was at the time. I kind of like to call it a proto-Earth, because it was not exactly like the way it is today. So it collided with our, proto-planet, and all of the debris that came up from this collision was shot out into space and then eventually coalesced to form our moon. And some evidence that we see that this could be the case is that the moon and the Earth are found to be made of a lot of the similar material, a lot of similar material. So it's very likely that they formed basically from all of this material that happened in this collision. So some of it went back into the Earth, it got gravitationally captured and went into making the Earth, and then the same thing for the moon. So this particular hypothesis is called the giant impact hypothesis. And from then on, the moon was incredibly hot after that formation, and we can show you a video of kind of like the moon's evolution over the past 4.5 billion years. And this video was made by the Lunar Reconnaissance Orbiter, which again is another way that we know what the far side of the moon looks like. And so we're going to be starting right after the formation of the moon, when it was still extremely hot, made of molten rock. So was the Earth. So this was about 4.5 billion years ago. And gradually over time, a lot of the less dense material kind of floated to the top and cooled, while the denser material sank down into the interior of the moon. And then a few years, not a few years, but 4.3 billion years ago, so shortly after its formation, was the formation or the impact that created the Atkin Basin, which is one of the largest craters in the solar system. So even though the moon's pretty small, it's got some pretty big features on its surface. And then there was a period where the moon was just being bombarded by material in space. Again, the early solar system was a very chaotic time. And so if a planet didn't have like an atmosphere or a magnetic field to really protect it, it could be easily bombarded by material out in space. And this is the period of volcanism. So all of those dark regions on the moon, they're called lunar maria or lunar mare, which comes from the word for seas, because a long time ago, folks thought that those areas were actually water or liquid of some sort. But we know now that it's actually material left over from these ancient volcanoes on the moon. So a lot of it is basalt and a lot of other rocks and minerals that I do not remember exactly which ones they are. Again, we have lots of craters, and we're getting very close to how the moon looks today. So it's been through quite the past, and here we are. Now we've sent missions, many missions to the moon, not just the Lunar Reconnaissance Rover or missions that orbited around the moon, but of course, we have sent people to the moon in the Apollo space program, which took place from the late 1960s into the early 1970s. And during that time, there were 6 flights to the moon and 12 people that actually walked on the surface of the moon. And they visited, so not the far side, but the side that we're facing. They visited kind of the equatorial region. And there's actually another mission planned to go back to the moon because it's been such a long time, called the Artemis program. Artemis in mythology is the twin sister of Apollo, which is very fitting because this will be the first mission to have the first woman and the first person of color to land on the moon. So it's going to be very exciting, but they're going to be landing in the South Polar region because it said there are some craters down there that have been mapped by the Lunar Reconnaissance Rover that have the bottoms of which have almost never ever seen sunlight throughout billions of years because they are very deep. And so therefore, they are actually some of the coldest regions on the moon, but they might contain a lot of water ice, which would be great if we ever wanted to build a moon base, perhaps, and have people on the moon all the time. It might make a really good place for that if there's access to a lot of water. So stay tuned for that. That is the Artemis program. Artemis 1 is scheduled to launch in a year. Artemis 2 is a year after that. Artemis 3 ideally would be by 2024. That is probably not going to happen. All of this is probably going to be shifted a few years down the line, but that is the plan for the decade, which is pretty exciting. All right, before we move on to Uranus, have we had any questions about the moon, Emily?
Thank you, Katie. I'll start by saying that video was so cool.
Yeah.
The one of the formation of the moon. I loved that. I don't think I've seen that before.
It's one of my faves.
We have not had any questions coming in, and I still don't see. Oh, hold on. Let me check this out. Okay, so how far is the moon from the sun?
From the sun, it's about the same on average as the Earth because the moon is orbiting around the Earth. So it's about 93 million miles away from the sun, which I know sounds like a very large distance, but if we look at the orbit of the Earth and the moon compared to the outer planets, or especially Uranus, where we're going to visit, this is the outer blue line here is Uranus, we're pretty close by.
Very cool. Thank you. I don't see any more coming in, but we can definitely answer more questions about the moon later on if they do end up trickling in.
Awesome. Sounds good. All right. So our next stop will be to the outer gas giant Uranus. So this, excuse me, not this blue line, this one, this paler one right here. I forgot that Worldwide Telescope likes to include Pluto in its planets here. Let's see. There we go. Now, Uranus is extremely far away from the sun. It's almost 2 billion miles away from the sun. So it would take light several hours to travel that distance. The Earth is about 8 light minutes from the sun. So it takes light 8 minutes to travel from the sun to the Earth. But going out to the outer solar system, out to Uranus, it would take a few hours in order to actually get out here. But it's a really cool planet. And I know that most of the time people, the only thing they really know about it is that it kind of has a funny name, which is true, but there's actually some funny history behind the name. So Uranus was discovered back in the early 1700s by a guy named William Herschel. And when he found it through his telescope, and Uranus was the first planet to actually be discovered because the other planets you can actually see in the nighttime sky with your naked eye. So Mercury, Venus, Mars, Jupiter, and Saturn, those can all be seen with the eye. So technically the first planet ever discovered was Uranus because you had to use a telescope to find it. But when he discovered Uranus, he actually wanted to name it after the King of England at the time, who was King George III. So he was going around calling it George for quite a while. But it didn't actually fit in very well with the name or the nomenclature of the rest of the planets, because all of the planets are named after the Roman versions of Greek gods or heroes or goddesses in the case of Venus. So I didn't really fit in with that. So eventually astronomers changed it to Uranus, which is the Latinized version of the Greek god Uranus. And it's the only planet where its Latin version does not match the Greek version. So it's a little bit different still. But that is where its name comes from. And that tends to be why you'll hear most astronomers or educators call it Uranus, just because it is closer to Uranus. But whatever way you're saying it, I guarantee you is correct. So no worries there. Now, this is actually one of my favorite planets because it is really weird. It's pretty much knocked right over on its side. So if you've ever seen a textbook image of Uranus, it looks like it has been knocked over because Uranus does have a ring system. And I'm trying to see if I can spot it at all in Worldwide Telescope, but it doesn't seem like you can actually see it. But if you did see a textbook image of it, you'd see the rings, they would be going vertically instead of horizontally like Saturn's rings are. And that's because Uranus actually is knocked over on its side. Astronomers believe a few billion years ago, at least one, probably two objects collided with this planet, knocking it right over, causing its tilt to be 98 degrees. So Earth's tilt is about 23.5 degrees, and it's the reason that we experience seasons. So as the Earth moves around the sun, the tilt relative to the sun changes depending on where it is. So when the northern hemisphere is tilted toward the sun, we have summertime. But then as the Earth travels around its orbit and gets to the opposite side, now we're facing away, we're tilting away from the sun. And so we experience winter up here in the northern hemisphere. So that's how seasons work. But on Uranus, because it's knocked over completely on its side, during the northern hemisphere summertime, its north pole is pointed directly at the sun. And so its summer season lasts for about 21 years because it takes 84 years for Uranus to orbit around the sun. And it's always daytime. It's never actually, it never goes into darkness at all until it's kind of equinox area. Same thing for wintertime. When it's the wintertime, that North Pole is going to be facing directly away from the sun, and you will be in darkness for a very, very long time. During the equinox times, so like the fall and the springtime, when the sun is shining on its equator, its equatorial region, that for that particular time of the year, it actually has fairly regular day and night times. One whole rotation of Uranus takes about 17 hours. So you go from having, years and years and years of the same day or night to having a few hours of day and night because of Uranus's very extreme tilt. So that's kind of a cool fact about this planet. It's just that it has really, really weird, wonky seasons. It's a gas giant, so it does not have a solid surface. It's made mostly of hydrogen and helium gases, but there is also some methane in there, which is actually what's giving it that beautiful blue color. There's also, so if you think about the chemical formula for methane, it's equal to CH4, and the C stands for carbon. Now, on gas giants, there's a whole lot of atmospheric pressure because they're made entirely of atmosphere pretty much. So the deeper you go, the more pressure you would experience. So if you think about it just for a sec, what happens to carbon when you put it under a ton of pressure? Well, you get diamonds. So astronomers actually think that it could be raining diamonds on the interior of Uranus if you go down far enough. And actually the same is probably true for Neptune as well, because Neptune and Uranus are very, very similar planets. Uranus is a little bit bigger in terms of volume. So if you could open it up like a cookie jar, you could fit about 60 or just over 60 Earths inside of it. So it's one of the smaller gas giants, but definitely not, super tiny. And because it's so massive, it has a lot more gravity than the Earth does. So it's able to hang on to a lot of moons. And let's see, I think I can turn the moons on because it's got quite a few. Let's see, it looks like they are all turned on. Aha, here we go. Oh, wow. There we go. Now you can really see just how many moons there are in orbit around Uranus. We can back all the way up and we're seeing all the moons in the whole solar system. Oh man, I need to turn off all the other ones. Let's see. That helped a little bit. We'll get rid of Pluto and Neptune as well. Okay. That should help a little bit here. So we can see that there are some moons orbiting pretty far away from Uranus. So here I put the sizes back to normal just so that it doesn't get super confusing. The moons that are far away from Uranus, you can see they're kind of all in these really chaotic orbits, and that's because those moons were probably captured. So an object floating from like the asteroid belt or the Kuiper belt, which is an asteroid belt that's farther out, it's past Neptune, it's full of icy, rocky objects. But one of these objects may have been floating by and Uranus's gravity could have snatched it up and they got stuck in orbit. So that's why you get all these really crazy orbits out here. But as we get closer in, you'll see the moons that probably formed with Uranus. So all of these are kind of in line with Uranus's equatorial plane. And remember, it's on its side. So it's all of the moons are kind of orbiting vertically around Uranus. And so the moons also have really weird seasons as well. But there are 5 major moons around Uranus. There's Titania, Oberon, Ariel, Umbriel, and Miranda. They are all named after the works of William Shakespeare and Alexander Pope. As a matter of fact, all of the moons are, as well as all the features that are on the surface of these moons. And they're pretty interesting worlds all on their own. So I can show you some pictures. And these are actual pictures. The only spacecraft that has ever actually traveled to the outer gas giants, Uranus and Neptune, is the Voyager 2 spacecraft. So they've never gotten dedicated spacecraft to actually study those moons or those planets or anything like that. So I think it's about time we go back, but we do have some really cool pictures from Voyager 2. So this is Uranus's largest moon called Titania. You can see it has a lot of like gashes and of course craters all over the surface. You'll find that's pretty common throughout moons in the solar system. They are mostly made of ice and rock, but you can see lots of plains and rifts and what's called scarps all over its surface. All right, this is Oberon. So Oberon is the second largest moon, and you can actually see that it's got kind of a reddish color. So some of Uranus's moons are outside of its magnetosphere. So the Earth has a magnetic field because of its core. Uranus has a magnetic field probably because of charged ices in its upper atmosphere. So the magnetic field is generated from a different mechanism, but it does have a magnetic field and thus a magnetosphere. And the moons that orbit outside of that magnetosphere have a bit of a reddish color because they are more strongly affected by radiation from the sun. So the farther out you get, the redder objects tend to get because they are exposed to more radiation. And then we have Ariel and Umbriel, which are very similar moons. Ariel is brighter just because of what's on its surface, more ices, things like that. But you can see lots of gashes. And then my favorite moon of all around Uranus is Miranda. Now this moon looks absolutely wild. It has cliffs and craters and mountains and glaciers. Astronomers even think that there are cryovolcanoes on the surface of Miranda, as well as the other moons of Uranus. But those cryovolcanoes actually shoot out ice instead of lava. And if you look at the bottom here of our picture, this section, it kind of looks like someone just took a chunk out of this moon. That is the tallest cliff in the entire solar system. And it's about 12 miles high. Astronomers used to think it was only like 3 to 6 miles high, but recent observations have shown that it is actually 12 miles high. But Miranda is a very small moon. It's actually thought to be the smallest known object that is still round in our solar system. Because in order to be round, you have to have enough mass. You need to be made up of enough material to pull yourself, or gravity to pull you into a round shape. And Miranda is just about as small as it gets, while still being round. And so theoretically, if you could ever jump off of one of those cliffs on Miranda, because it's so small and doesn't have very much mass, its gravity is also very weak. It's only about 1% the gravity, the strength of Earth's. So you could just jump off and float all the way down. And one of my favorite pieces of science fiction, it's a short film by Eric Wernquist. I don't know if that's how you say his last name. It's Swedish, might be Wernquist. But he's a digital artist, and he created a short film that's free on YouTube, and Carl Sagan actually narrates it because it's from his audiobook Wanderers, and that's what the video is called, Wanderers. And there is a scene in it where people in the very distant future are base jumping off of the cliffs on Miranda. So if you have a chance today, it's just a couple minutes long. I highly recommend checking out that video, Wanderers. All right, that's all I got. So Emily, do we have any questions?
We do. Thank you, Katie.
Yeah.
Someone is wondering, how cold is Uranus? But also, if you were to go to the moon, would it feel hot or cold when you stepped on it?
Yes, good questions. So Uranus is extremely cold. The areas around it, so like if you were standing on, because you can't stand on Uranus, but if you could stand on the moons around it, it would be over negative 300 degrees Fahrenheit. So it would be extremely cold. And yeah, if you stood on any of the moons, very, very cold.
Okay, thank you. Let's see. I think I just have one more question. This one's about the moon. Why did the moon not get sucked into the Earth as the Earth was forming?
Yeah, that's another really good question. So there's kind of these points around objects that are very massive that are called, they're like stable points, gravitationally stable points, and material will tend to stay in those orbits. And so as long as an object is moving fast enough, it will stay in orbit. So all that material, if we just pretend that Uranus is the Earth for a moment, and you had something collide with it, that material is going to get kind of flung out into space. It's going to be moving very quickly. And so if it gets flung out here and then starts to orbit around, it's never actually going to fall because it's moving fast enough to always miss the planet. So that material can easily just clump together and then stay in a stable orbit around the Earth. But the same thing with like Uranus's moons. These moons clump together and they didn't fall into Uranus because they're moving faster than the curvature of Uranus, if that makes sense. They are in free fall, but they're moving very fast, so they will never actually go into the planet. Same thing for our moon. It will never actually fall into the Earth because it is moving fast, and it's actually getting farther away just a little bit every year. So, in billions of years, we won't have a moon anymore.
So cool. Thank you so much, Katie. Do you want to say goodbye to everyone before we close up?
Yeah, bye everyone. See you next week for our last program. That will be Mars and Neptune.
Very cool. Okay, so folks, thank you so much, as always, for joining us today. I always see familiar names in our attendance week after week, so thank you so much for joining us again. Let me put up our closing slide for you all. If you're interested in actually using the program that Katie was using today, it's called Worldwide Telescope, and you can visit worldwidetelescope.org to check it out. If you want to see more of our virtual offerings, you can go to mos.org/mos@home. And then if you would like to support the museum, you can visit engage.mos.org/welcome. So with that, we will see you next week. Bye. Thank you, everyone.